Um, Hello, welcome back to the continuing lecture in investments. Um, Now we are moving on to the diversification of portfolio in single index model, right? With single index model. Now, basically, a single index model is a um, excess return, right? Excess return model based on the you know risk premium correlation between the risk premium in uh, market index market portfolio and market index portfolio, right? And individual uh, asset uh, risk premium in individual asset, right? So it's uh, then what more diversification are we talking about here? What more diversification can we? Um, a market portfolio is already a well-diversified portfolio. It may not be a perfectly diversified portfolio, but that's as much as we can do, right? That's the best we can do given um, that market index like S&P 500 reflects pretty much the broad spectrum of the economy. But then if you think about it, um, just holding on to a market index, a market portfolio, um, it's like in a way, uh, passive portfolio, right? I mean, think about it. If you are, holding a market portfolio, right? You don't have to do anything. I mean, whatever the market gains or loses, right? You will get exactly as much return as bearing as much risk as the market, only as much as the market, and you will be earning only as much as the market return. So and you don't have to do anything. In that sense, it's a passive portfolio. It's a passive portfolio management, right? Then what's the point of security analysis? I mean, um, can we um, uh, if we just make just a little more effort and identify assets that have like uh, that have positive alpha, right, and adding those to the um, think about it. If we adding positive alpha assets or stocks to the market portfolio will always do something, will always give you something better than the passive, the return on the passive portfolio. Isn't that right? So the idea is, yeah, we can do the passive management, passive portfolio management, but if we take uh, one more step, if we, analyze the stocks and identify, positive alpha stocks and add it to the market portfolio, and we will uh, we will have a better return, or not just better return, but obviously with positive alpha, there may be added risk, right? In other words, some may have it's like cost benefit ratio. I mean, the additional stocks that you're adding to your passive, if you're adding additional stocks to the passive portfolio, the portfolio is um, obviously that's an optimal risky portfolio, right? Because uh, it's already risky, right? Um, and the composition of our next question is, okay, I'll pass. How much of our how much weight do we allocate to the passive portfolio, and how much to that extra additional stock, right? So if we find the optimal weight, then that will be our optimal risky portfolio, and it is also our active portfolio because we did active, security analysis. Actively, we uh, did security analysis and actively identified stocks with, positive alpha. So we construct a portfolio consisting of, passive uh, market, portfolio and plus these, positive alpha stocks. So uh, it is active portfolio now, right? Um, but as I said, the question is, with added alpha, with additional alpha, the stocks that have positive alpha may come with, uh, the wider variance, right? And we know the variant. We know that the variance is taken care of by um, the market portfolio takes care of, the systematic part is taken care of uh, by, beta, right? Uh, and by uh, the additional stocks will come with, its own firm specific errors, firm specific risks, which are basically the errors, right? Um, so by active portfolio, we are not only getting better return, higher return, but the risk will go up as well. But I said, it's going to be like a cost benefit analysis because alpha is the benefit and the firm specific risks that are incidental to additional firm specific um, risks that are incidental to these uh, positive alpha stocks, adding these positive alpha stocks, that's the cost. And we know, taking the benefit cost ratio, comparing uh, uh, the a very straightforward and simple law behind, cost benefit analysis is as long as the benefit exceeds the cost, then there's a net gain, right? Net gain. And the ratio should be greater than one. I mean, if benefit exceeds cost, then the ratio should be, greater than one. That's, indisputable, straightforward logic. So the idea is, even though there will be um, added, firm specific risks, right? As long as the Sharpe ratio is increased, the Sharpe ratio of the active portfolio is higher, and it is all worth. I mean, that justifies, the act portfolio management, right? It's all worth the trouble. Now, so first of all, once again, it's all the question of, what is the optimal weight distribution? So in a portfolio of n securities with weights, of course, all the weights will have to sum to 1, right? If you sum all the weights, then it has to be 1. Now, in securities with non-systematic risk, right? Systematic risk is, explained already, by beta. Non-systematic risk, which are the unexplained errors, right? Remember? Right? The variance is, the total variance breaks down into the systematic variance, right? And non-systematic variance or unexplained variance, which is firm specific. I mean, regression cannot explain the firm specific errors, right? A firm specific risks. Non-systematic risk is basically the variance of the error terms, right? It's also called residual, right? It's regression error, right? In other words, a regression line cannot, hit all the scatter plots, right? It will only can only explain the plots that fall on the regression line, and the ones that are not falling on the regression lines, the difference between the height of the regression line and the individual scatter plots, that difference is called, residual or error, forecast error, or regression error, right? And in those errors, the correlation between those errors are, completely, zero. In other words, there's no correlation whatsoever, right, between these errors. Which means, these errors are not, because they are all different industries, coming from different industries. So these are firm-specific errors, right? And the firm-specific errors would have zero correlation with each other. Okay. So non-systematic portion of the portfolio return, which is error, right? And of course, E sub P, this piece, stands for portfolio, of course. Portfolio error is basically sum of all the errors weighted, right? All the individual errors, right? Weighted, right? Goes without saying. And then portfolio, the non-systematic variance of the portfolio is, and we know that means, a variance of the portfolio errors. And then that's, the weight, weight times, weighted average of, weight times, and, individual standard deviation squared. All of them squared, so it's weight squared and variance of non-systematic errors, right? Residual or firm-specific, risks. That's Sometimes repeating the, I mean, there are so many ways to pull them, so it's important to constantly remind yourself that A is also B, which is also C, I mean, which is also D, and A, B, C, and D are not different things. They are just different terminology, all referring to the same thing. Okay? And let's think about, what this means. If N, in other words, uh, number of, assets in the portfolio, if N goes to a big number or large number, right? Uh, the weight squared will be a very small number, right? Of course, now think about it. If we have 100 assets, suppose we have 100 assets, right? If you have 100 assets, and suppose, everything, if you have 100 assets in your portfolio and, what would be the weight? Obviously, the weight, I mean, even if they are all held in equal proportion, then the weight will be, 1%, right? 0.01. And that weight, suppose, 1% weight squared, what's it going to be? It's going to be, 0.0001. It's going to be still very small number. I mean, think about it. You are multiplying, if you have 100 assets, all 1%, 1% square, it's not square, 1%, it's going to be 1% raised to 100. If 1% is raised to 100, what's it going to be? It's going to be an infinitesimal number. Infinitesimal, right? So that's why, a well-diversified portfolio, um, the we already know the firm-specific risks go down drastically, right? And the wait times, these variances will be a very small number, right? It will be therefore will be negligible regardless of rho, regardless of correlation, it will be negligible. And why number of securities counts more than the size of the error variance, more than the size of the, okay, regardless of the, um, and also we have to, I mean, this is the next, I ran out of space, so I had to put it here. So to find this weight of an additional stock, positive alpha stock, we have to use the Trainer-Black model. What's called Trainer-Black model. Trainer-Black. Remember, we talked about Sharpe ratio and then Trainer ratio. You probably remember, Sharpe. As when we did Sharpe ratio, we talked about Trainer ratio as well. Trainer ratio. I think, was it here or the previous? Maybe in the previous chapter, right? Trainer, Sharpe ratio, and Trainer ratio. So Uh, so what is the trainer black model? So suppose, we are adding Google, right? Suppose we are adding Google to our uh, uh, passive portfolio. So our active risky portfolio will include, passive market portfolio and Google, right? What should be the weight of the Google then, right? And what, of course, then if Google's weight is, let's say weight of Google is, optimal weight is, let's say, uh, uh, 20%, right? And what is optimal weight? Optimal weight is, of course, the weight uh, that maximizes the Sharpe ratio of this portfolio, right? Always is the Sharpe ratio, right? And if the weight of Google in this portfolio is 20%, then weight of the passive portfolio will be 80%. Makes sense? So, so we need to estimate the information ratio for Google. What's an information ratio? Information ratio is basically alpha of the ratio between alpha and the standard deviation of the residuals or error terms. Okay, why? Because I told you, the error terms, regression errors or residuals are firm-specific errors. So what is this ratio? What is this ratio actually telling you? What is that? Actually, what is the meaning of that? Meaning is, it's like a benefit to cost ratio, benefit cost. Isn't that right? Think about it. By adding Google to our portfolio, right? Current, past, uh, you know, uh, risky portfolio, which includes, already, passive market portfolio, and we are adding Google to that. By adding Google, right? Uh, you might you might wonder, isn't Google already including the passive portfolio? Oh yeah, yeah, but let's say Google is relatively new company and currently not in uh, not in S&P 500. I mean, if you use S&P 500 as our market portfolio, again, and it is true. Google is in Nasdaq, not part of S&P 500. It's part of Nasdaq. Most of the tech uh, companies are on Nasdaq. So it's like if you combine, if you're holding, Nasdaq and uh, of course, still, I mean, you can construct a portfolio. You can construct a uh, optimal risky portfolio consisting of uh, uh, S&P 500 market portfolio and Nasdaq portfolio, right? Nasdaq portfolio and Treasury bond risky bond portfolio, right? I mean, of course, complete portfolio would have, then Treasury bill risk free, and the weight will be if the risk free and the weight between the risk free and the risky portfolio is 20/80. And with this 80%, how much do we allocate? And again, the weight distribution, how much will go into active portfolio plus, the stock portfolio and the bond portfolio, and even, within the stock portfolio, how much goes into the Nasdaq portfolio how much what weight goes into the S&P 500. I mean that can be that will be another next level. But let's say to the passive portfolio of S&P 500, if you are adding Google, right? There's a benefit definitely derived from Google because you won't add Google to your passive portfolio if Google isn't coming with uh, positive alpha, right? But at the same time, it will be adding to the uh, risk of the variance of the uh, uh, passive portfolio, right? Uh, which is uh, Google's own firm-specific errors, right? Google's own firm-specific errors, which is I even moved like 2 slides. Uh, so that's information ratio, information ratio. So think about it. We want this information ratio to be greater than 1. The greater the number, the better it is. Of course, we would want it to be the higher the number, right? Because if this ratio is greater than 1, it's obvious, you get more bang for the buck. You're getting more bang for the buck, right? You get more return you get more benefit for additional risk, right? You get more return for additional risk, you get more gain or benefit for additional cost, okay? So looking at this, I skipped, so many slides. How did that happen? So where I should have been was this, so of course, RG, uppercase RG, subscript Z, R, uppercase R, subscript G implies Google excess return. So Google's alpha, which is alpha G, right? Which is uh, what is alpha? It's the difference between Google's excess return and market's excess return, right? It's the vertical intercept. That is, when when market has no excess return, right? Market excess return is 0. Of course, that's the definition of alpha, right? Definition of alpha, alpha is vertical intercept. For to find vertical intercept, our x must be 0, right? So our x is market excess return, right? If market excess return is 0, then this beta G times RM will be 0. So and the excess return on the Google at that point when market return is excess return is 0, that's alpha. So we use 2 key statistics, information ratio, and RM over excess return on the market over a systematic variance of the market, right? Variance of the market. Variance of the market is the systematic risk, right? To find the position of Google optimal risky portfolio. Oh, the uppercase O always means, optimal risky portfolio, right? So, in other words, that means, Google's position, right? Which means, Google's weight. Okay, which means Google's weight. And then, I don't, when it is in PowerPoint, this is, hyperlinked, but, you can't click it when it is. Of course, if I turn it into a slideshow mode, I can click it. I don't have to click it because I'm gonna. Let's take a look at what these two key statistics actually mean. We know this is information ratio. This is, this is like, benefit cost ratio of adding Google, and this is, benefit cost ratio of the market portfolio, right? And if you think about it, benefit cost ratio of market portfolio is like, it's like what? It's like Sharpe ratio. It's like Sharpe ratio. What's the difference? I mean, why don't I call it Sharpe ratio? I mean, why do I say it's like Sharpe ratio? It's not exactly Sharpe ratio, but it is close. Why? Because in case of Sharpe ratio, the denominator is the standard deviation variance, right? But variance would be the smaller of the two, because these are the numbers that are between 0 and 1. 0 and 1. Standard deviation is something like, still standard deviation is, some percentage, right? Because we're dealing with returns. So it's a number between 0 and 1, and when squared, it will be smaller still, right? Let me quickly, if I click on this, will take me to the slide where you will find the footnotes for everything, which is slide 40. But we're out of time, so I guess we will have to talk about it. I wanted to talk about it in the next video, and I'll have to stop recording at this point. So I'll see you guys in the next video. Stop recording.